Hi everyone, I'm Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today I'm going to present the topic, the limits of exhausting search. In computer science, many problems can be solved by checking every possible solution. This approach is called exhaustive search or brute force. Um, the overcome this issue, two important techniques were developed: the backtracking, branch, and bound. So the promise stemming complexity, computational problems become difficult when the number of possible solution becomes very large. Backtracking help by building solutions step by step. Whenever it find a path that cannot lead to a valid solution, it immediately stops exploring the path. This saves time and memory. Branch and bound works differently. It focuses on optimization problem. It calculates an estimate called a bound and remove solution that cannot improve the current best answer. Both methods have the same goal, to solve difficult problems without checking every possibilities. These techniques are especially useful for NP hard problems where brute force method are practically impossible. They help computers solve larger problems more efficiently than exhaustive search. The core idea, both backtracking and branch and bound use a structure called a search tree. A search tree represents all possible decisions. Each branch represents a choice. Each node represents a partial solution. The algorithm starts from the root and explore different branches. As it moves deeper, it builds possible solution. At each step, the algorithm evaluates whether the current path is promising. If a branch cannot lead to a useful solution, it is pruned. Pruning means cutting off unnecessary branches without exploring them fully. This reduces the amount of work dramatically. The difference is that backtracking prunes in invalid solution, while branch and bound prunes solution that cannot become optimal. Yeah. The fundamental limitation, exponential growth. Even with pruning, a major problem remains. Many computational problems grow exponentially. This means that as the input size increases, the number of possible solutions increases extremely rapidly. Consider the traveling salesman problem. With only a few cities, the problem is manageable. The bottleneck bounding function efficacy. Branch and bound depends heavily on its bounding function. A bounding function estimates whether a solution is worth exploring. If the bound is weak, the algorithm cannot eliminate many branches. As a result, it behaves almost like brute force. If the bound is strong and accurate, many unnecessary branches can be removed early. This significantly improves performance. However, there is a challenge. Strong bound are often difficult and expensive to calculate. Therefore, there is always a trademark between accuracy and computational time. Designing effective bounding function is one of the biggest challenge in optimization algorithm. When backtracking failed n-Queen's problem, the n-Queen problem is a famous example of backtracking. The objective is to place n-Queen on a chessboard so that no queen attacks another queen. For small values of n, backtracking works very efficiently. For example, with 8-queen solution can be found quickly. When branch and bound stumbles, real world scale. Branch and bound works well for many optimization problems. However, real world problems often contain thousands of variables and constraints. Consider vehicle routing. Companies must determine efficient routes for hundreds of delivery vehicles. Similarly, airline crew scheduling involve many rules and restrictions. In such cases, creating accurate bounds becomes difficult. Poor bounds lead to poor bounding. As a result, the algorithm may still need to examine a large number of possibilities. The runtime becomes too large for practical use. This demonstrates the Branch and bound can struggle when applied to large scale real world problems. The curse of dimensionality. The curse of dimensionality refer to the difficulties caused by increasing number of variables. As more variables are added, the search space expands rapidly. Imagine searching for a grain of sand on a beach. Now imagine the beach doubling in size every minute. Finding the grain becomes increasingly difficult. The same happens in computational problems. So beyond exhaustion, heuristic and approximation. One approach is heuristic. Heuristic provide good solution quickly but do not guarantee the best solution. Another approach is approximation. These algorithm provide solutions that are close to optimal with mathematical guarantee. The third approach is hybrid. For example, a heuristic may first identify promising region and then branch and bound may search within those region. And the powerful tools to conclude, backtracking and branch and bound are extremely important algorithmic techniques. They help reduce unnecessary computation and solve many difficult problems. These are the mind map for this this growth. Thank you.